You are watching Darasa Online.
Okay, we are going to discuss or focus more on weather and climate. So, what is weather and what is climate? Weather refers to the average atmospheric condition of an area which occurred and recorded for a short period of time. Example, it may be after 2 hours, after 1 hour, after 30 minutes, etc. For instance, let's say it rained in a certain area for 30 minutes and then it disappear. We call it average atmospheric condition of an area which occurred for a short period of time. Let's say, take an example, temperature of an area. Temperature of an area may be high for maybe 6 hours and then it may fall down. See, so the change in condition of the atmosphere for a short period of time, we call it what? The weather condition. Then we have what we call the climate. Climate will refer to the average weather condition of an area which occurred in a long period of time. It may be over 30, over 80 years, etc., etc. So from there, as I said, we focus much on what we call weather and what we call climate. So let's get back to on what we call space dynamic as a topic.
You are watching Darasa Online.
As when you say space dynamic, space will refer to the atmosphere. Dynamic, it means something is not stationary. Different events occurred at the atmosphere, which will result or may affect the area or a certain area and result to different events or phenomena on the Earth's surface. For instance, we have floods, we have what we call famine and hunger, drought, global warming, etc. Those are the events which are the results of what? Of the change in different events or the condition of the atmosphere. That's why you say space dynamic. It means the space is not stationary. It is not resting. It is occurred in different times. So from there, as I said, we are going to stick much on weather and climate. Climatology will refer to the branch of science which study climate in terms of origin, nature, and the spatial distribution all over the land surface, which at the end it influences the life of flora and fauna as well as the environment they exist. So our point is, as I said earlier, refer to the branch of science which study climate in terms of origin, nature, and the spatial distribution. Let's stick there. What does it mean when you say it study climate in terms of origin? Origin, it means we are talking about the causes of that climate. For instance, if it is a hot climate, what caused it to be hot? What caused it to be warm? If it is a cold climate, what caused it to be cold? What caused it to be cool climate? You see, when you say nature, it means the characteristics of that climate, either it is hot or it is cold. And when you say spatial distribution, it means you are talking about the variation of climate in different areas. We call it spatial distribution. So going back to the definition of the climatology, that's why I say climatology refers to the branch of science which study climate in terms of what? In terms of origin. I said the origin will refer to the causes of that climate. Nature, it means we refer to the characteristics of that climate. Is it hot or cold? It means that it is the nature of the climate. What caused that climate to be hot or cold? It means we are talking about the origin, the causes of that climate. And the spatial distribution all over the land surface. It means we are talking about the variation of that climate in different areas. When you go to the pole or to the polar area, you find the climate of that area is cold. When you go to the equator or around the equator area, you find the climate of that area is hot. So the word hot, I repeat, hot or cold, nature of the climate. What caused it to be hot or cold? It means we are talking about the origin, the variation of that climate in different area over the land surface. We call it the spatial what? The spatial distribution. Okay, from there, we know that climate of a given area may affect the human life, both plants and animal, in the environment they exist. I mean this, it may affect you and all others living things that surround that area. For instance, plants, I'm talking about different vegetations that cover that area, or I'm talking about when I say flora, it means flora are plants, fauna refer to animals. So we have different places covered by both of these living things. So it may affect the living things from that area as well as the environment they exist. When I'm talking about the environment, I'm talking about the surroundings, see, including rocks, water bodies, etc., etc. Then from there, I said climatology. Apart from this, climatology can be simply defined as the study of climate, because the word climatology, it comes from the word climato, which means climate, and the word logi, which means what? Study. So simply you can say climatology will refer to the branch of science which study climate. Then from there, as I said earlier, today we are going to discuss on climatology or space dynamic, and we are going to see some of the very important questions. Why I say they are very important questions? Because they are most occurring questions. So let's see them. I'm going to write them so that you can mark down. Later on, we are going to see the model questions, where we are going to see how to answer them, okay? How are we going to answer those questions? Okay, we're going to see most of the occurring questions based on climatology. So you as a student, because we are going to make revision on climatology, you have to focus on these 5 examples or key points on your questions regarding climatology. So the first one is you have to know factors affecting the climatic change. Factor affecting the climatic change. What caused the climate to change, see? Then from there, you have to make sure that you know factor affecting the insolation rate. It means at this point, you have to learn or to study what is insolation. Then from there, you'll be able to know what are the factors affecting the insolation. Thereafter, we have the factor affecting the temperature of an area. So you have to make sure you study what is temperature, measurement of temperature, what are the key points on temperature when you read temperature. Then from there, you have to make sure you know factor affecting the temperature of an area. This is very important. As I said, this is the most occurring question based on the climatology. Then from there, you have to know what is the atmospheric heat budget, or sometimes you have to know what is heat budget. Then from there, you have to know what is lapse rate as well as the temperature inversion. You have to know the causes of lapse rate, type of lapse rate. Then you have to know the causes of temperature inversion. What is temperature inversion? Causes of temperature inversion as well as the type of temperature inversion. Then from there, you have to know the importance of climate on human nature or human life.
You are watching Darasa Online.
By making revision, it will be easier for you if we will go directly and see different questions and how to answer them, where most of them are competent questions. So now we are going to make different revision based on these parts of climatology. So what am I going to do right now is that we are going to discuss or to see different questions. These are the competent questions. Why do we say they are competent questions? Because they are not asked direct. See, they ask questions with, I mean, they need you to identify the key needs of the questions. Thereafter, you have to know how you're going to answer your questions. So let us see some of the examples of those questions and how to answer them. Okay, welcome. Let us start with the first question. The sun produces 100% of the solar output, which travel a distance of about 152 million kilometers to reach the Earth in 9 minutes, whereas 53% of it is lost at the atmosphere or in the atmosphere, and only 47% of it reaches the Earth. So explain 7 factors affecting the amount of solar energy received by the Earth. So you have to pause there, okay? You have to need to see what are the needs of the question. Right now, they need us to explain 7 factors affecting what? The amount of solar energy received by the Earth. So I'm going to answer the question by focusing on what the question needs. You see, the question right now, it needs us to explain the factors affecting the amount of solar energy reached by the Earth. What does it mean, by the way, the amount of solar, from here, amount of solar energy received by the Earth? You see, we refer the amount of solar energy received by Earth, we call what? We call the insolation. Insolation will refer to the amount of solar energy received by the Earth. So let us see what is insolation, how do insolation occur, how do the solar energy travel from the sun up to the land surface. Okay, let us focus on the needs of the question. As I said, the question number 1, it says the sun produces 100% of the solar output, which it traveled a distance of about 152 million kilometers in 9 minutes to reach the Earth. You see, thereafter, the question needs us to explain what we call the amount of solar energy received by the Earth. It needs to explain the factor affecting the amount of solar energy received by Earth. So by reading the question, you can know, or you can determine, you can identify the key needs of the question. The question needs us to explain the 7 factors affecting the amount of solar energy received by the Earth. I told you the amount of solar energy received by the Earth, we call it the insolation. Need of the question. It means the question needs to explain factors affecting the insolation. See? So, factors affecting the insolation. So, what is the insolation? See? What is insolation? Insolation. What is insolation? Insolation will refer to the amount of solar energy received by the Earth from the sun. It means the sun, it emits 100%. So this is just the history of how do solar energy received or reach the Earth's surface. So let us take an example. Somewhere there, this is our sun. Then we have the land surface right here. It means right now the sun emits the solar energy. So right now the solar energy travel from the sun to reach the Earth. This is the land surface. Earth sometimes we refer to land surface. It means the sun travel. I mean the heat energy from the sun, it travel to about 152 million kilometers from this point to this point. It's almost 152 million kilometers in 9 minutes. 9 minutes to reach the Earth. But we found that only 47% of total solar energy received by the Earth. Whereas the 53%, it means the 53% of the solar energy from the sun, it lost at the atmosphere. It lost at this point right here. It means right here we have 53% of the solar energy lost. It does not reach the Earth's surface. Where the amount of the solar energy received by the Earth, and we call it the insolation, is only 47%. So what happened right here, it is that we found this 53% of the solar energy, it's either scattered, it undergoes scattering. It means there are material which scattered the solar energy from the sun to reach the Earth's surface. Either it reflects back the material, or sometimes it may absorb the solar energy. It may absorb the solar energy from the sun. So, because there are these 3 processes which occurred right here at the atmosphere, we found the only 47% of the total solar energy is received by the Earth, whereby 53% of the solar energy is lost at the atmosphere by either scattering, either reflection or absorption. We know there are different materials, for instance, cloud, which make a reflection of of solar energy back to the atmosphere, or it may absorb. For instance, water droplets or ozone layers, they may absorb some of the solar energy. Some of the materials, they may scatter. They may do scattering. Scattering means reflect back to different direction. You see, reflection as well as the absorption. So from there, you may find only 47% of the solar energy received by the Earth, and we call it what? We call it the insolation. Insolation. So from there, I know right now you have understood, or you have understand what is insolation. Insolation refers to the amount of solar energy received by the Earth. The amount of solar energy that reaches the land from the sun is what called the insolation. So there are different factors which affect the amount of solar energy to reach or received by the Earth. Factors that affect the amount of what? Of insolation. Okay, as I've said that we know right now we know what is insolation. From there, we can. Right now we want to see, or we are going to see different factors affecting the insolation rate. Okay, so the first factor, it is solar output. Solar output we refer to the amount of solar energy emitted by the sun. So we know the sun, it always emits 100% of solar output. So it depends. Sometimes it may emit 100% of solar output, which is in a small rate, okay, which is in a small amount. So if the amount of output or solar energy emitted by the sun is small, then we expect the lower the insolation. But if the amount of solar energy or solar output emitted by the sun is high, is large, it means there will be much insolation on the Earth's surface. That is first factor. The second factor is distance of the Earth from the sun. Distance of the Earth from the sun. You see, right here we are talking about two periods. It means we have what we call the aphelion, and we have what we call the perihelion. Okay, dear student, we all remember what is aphelion, what is perihelion. Then from there, perihelion as well as aphelion, it always it may affect the amount of insolation received by the Earth. How? We know aphelion it occurs when the Earth is farthest away from the sun, while perihelion it occurs when the Earth is nearest to the sun. So during perihelion, where the Earth is farthest away from the sun, which occur on 7 July each month, it means at this point, where this Earth is farthest away from the sun, it means there will be the decrease in insolation rate. Why? Because right now at this point, the Earth is far away from the sun. But during perihelion, which occur on every January 4th, it means every year, this period is the period when the Earth is nearest to the sun. Nearest to the sun. So it means at this time, it's where the insolation rate is high. Why? Because the Earth is nearest to the sun. It means we expect high amount of insolation to the land. While during the aphelion, which occur on 4th July each year, it means it is the period where the sun, the Earth is farthest away from the sun. So at this period, it means we expect low insolation. This is the second point. Then the third point, we have the processes occurred at the atmosphere. As I said earlier, we have different processes which occurred at the atmosphere caused by the presence of different material. One among the processes is we call the reflection. You see, we have the scattering, and we have the absorption. These are the processes which affect the atmosphere or which occur at the atmosphere and may affect the insolation rate. How? We say there are different material which found at the atmosphere, example clouds, water droplets. You see, most of these materials, they tend to reflect back the amount of heat energy which travel from the sun to reach the Earth. It means it reflect back. Where it may reflect 19% of the total solar energy travel from the sun to reach the Earth. Then we have scattering. There are material which make scattering of of the solar energy which travel from the sun to reach the Earth. Most of these materials, they redirect light energy, heat energy to different direction. And there are material which absorb solar energy which travel from the sun to reach the Earth. This material we have, for instance, ozone layer, water droplets, etc., etc. So, if these three processes which will occur in the atmosphere, automatically will do what? Will reduce the amount of solar energy which travels from the sun to reach the Earth's surface. That's why we say only 47% of the total solar energy is received by the Earth, while 53% of it is lost at the atmosphere due to different processes which are reflection, scattering, as well as what? As absorption. So we take this three processes as what? As the factor affecting the amount of insolation. Why? Because we assume if there will be no this process occurred at the atmosphere, then we expect right here there will be 100% of the total solar energy which travel from the sun to reach this point or to reach the Earth. There will be the higher the insolation.
You are watching Darasa Online.
Okay, then we have another factor. We call it the latitude position. So it depends on latitude position of an area. So it depends where the area is located during the continental drift. It means during the formation of this, there are areas which have been located far away from the equator, and they normally assume very low temperature, especially at the pole or polar areas. And there are areas which are located at the equator where they assume very high temperature. So due to that condition, it means our point on how or where the land is located in terms of latitude, we find that most of the area located at the pole, they have low insolation. While most of the area located at the equator, they have high insolation. Then from there, so it depends either the area have located at the pole or at the equator. So area located at the equator, because normally the heat energy travel from the sun to reach this at perpendicular, while at the pole most of the heat energy travel to reach the area at the tangent area or at tangent angle. So you find at this point here, right here, we assume low insolation rate, while at the equator it will assume high insolation rate. Then another point is what we call the albedo. Albedo will refer to the specific capacity of an object. See, the specific capacity of an object. Specific capacity of an specific heat capacity of an object. So it depends. And right here we are going to see how land and water, because land and water have different specific heat capacity. So the one with high specific capacity will have high insolation rate, and the one with low specific capacity or albedo, it has low insolation rate. So land and water. Land, it has low specific heat capacity, so it has low albedo. So in that case, in land we have low insolation rate. Why? Because it receives fast and it loses fast. Why water bodies has high specific capacity? Why? Because it receives by much time and it loses by much time. So you may find that water bodies, they receive and lose heat very slowly. It means they assume or they show or they evidence high insolation rate. Land, it receives fast and it loses fast, so it assumes very low insolation rate. So it depends on the length of the day. So we say this during summer in the northern hemisphere, days are longer than night. It means because days are longer than night, it means it assumes very high insolation. While during the summer in the southern hemisphere, days are shorter than night. So it means during the summer at the southern hemisphere, it assumes very low insolation. While during the winter in the northern hemisphere, days are shorter than night. So while during the winter at the southern hemisphere, days are longer than night, which means at the southern hemisphere it will assume high insolation than at the northern hemisphere. Then from there we have the last point, which we say the angle of incidence of the sun rays toward the Earth's surface. Angle of incidence. So it depends. Angle of sun exposure toward the land surface.
You are watching Darasa Online.
Okay, the last point is angle of the sun exposure towards the land surface. So it depends on the how do the solar energy travel to meet the land surface. So if the solar energy meet at perpendicular with the Earth's surface, it means we assume there will be high insolation. But if the solar energy will meet at less than 90, I mean not perpendicular, the Earth's surface, it means at this point the land will assume the low insolation rate. I mean this way, let's assume that the sun it emits 100% of the solar energy which it travel to reach the Earth's surface. So we find this way. It is the sun right here. Then this is solar energy traveling to reach the Earth's surface. So you may find the solar energy which meet the Earth's surface at right angle, we say perpendicular. This point here, we assume high insolation rate, you see? While this solar energy, or heat energy which travels from this point to this point, will meet this point here at tangent area, I mean tangent angle. this point at tangent angle. So this area right here we assume low insolation rate. That's why you say it depends on the angle of the sun exposure towards the land surface. So if the sun, the heat energy will meet with the land surface at right angle, this point here the land will assume high insolation rate, while at this point the sun will assume what? The low insolation rate. Thank you very much. So from there, by referring or by making summary of the question, because the question needs us to explain the factor affecting the insolation rate. So the first point is that you have to explain the definition of the insolation. That insolation refers to the amount of solar energy received by the Earth after what? After the emission of the heat energy by the sun. It means there are amount of solar energy that you will reach by that, and we call it the insolation rate. Then from there, you have to explain different factors, as I have mentioned, and give some new key points on how to explain them.
You are watching Darasa Online.
The second questions are, it says the climate of an area influences the lifestyle of people in that area. Then it justifies the statement in 6 points. I repeat, the climate of an area influences the lifestyle of people in that area. Justifies the statement in 6 points. So in other way, the climate of an area, it may affect the lifestyle, the nature of the life of the people in different style. So the word justify the statement in 6 points. It means it needs us to prove. See, justify is different from discuss. Discuss, it means you can either go against or go with the question the way it needs. But right now, justify, it means we have to go with the way the question needs. Are we together? So we have to prove the statement that the climate of an area influences the lifestyle of the people living in a particular area. So by starting on, how to answer the question, it means we have to define what is climate. Then from there, you go direct to the point. How do climate affect the nature or the lifestyle of the people? So let's see how climate, because I know you know what is climate. We have already studied it earlier. We've already seen it earlier. You studied it at your school. So right now, because you know what is climate, let's go and see how do climate affect the lifestyle of different people. Okay, the following are the answers. How do climate affect the lifestyle of different people? The first point is feeding style. We have the feeding style as the first point. So listen to me very careful. People who live in hot climate, they are likely to have low food intake rate. See? While most of the people live in cold climate, they are likely to have high food intake rate. They eat much. People in hot climate, and people in cold or cold climate. These people who live in different climatic areas, they have different feeding style. For instance, I say most of people who found or live in hot climate, they have low food intake rate. And most of them, they take what you call light food. They eat chips, snacks, juices, etc. While most of the people who live in cold climate, these people, they have what you call high intake rate, high food intake rate. They eat much. Why? Because they need food for metabolic activity to produce heat so as to survive in the condition or in area where there is cold climate. That's why that's the first point, feeding style. Most of people live in cold climate, they eat much. While most of the people who live in hot climate, they eat less. Why I say that most of the people who live in cold climate, their bodies, they need more heat energy in order to survive there. So they need more food in order to burn the food to produce what? To produce heat. The second point is dressing style. Dressing style, see? Dressing style is influenced by a certain type of climate. For instance, most of the people live in hot climate, they are likely to dress in light clothes. While most of the people live in cold climate, they are likely to dress in heavy clothes. You may find them, those people who live in cold climate, they wear heavy clothes, either jacket, coat, scarves. While most of the people live in hot climate, they are likely to dress in light clothes. They wear what you call kanzu, Nsuli, Vasties. You see, you may see them walking on the street wearing those kind of dress according to what to the climate of that area. Another point is body or healthy condition. Body or health condition. We say this. Most of the people live in a certain type of climate. Their bodies may be affected by that type of climate. For instance, most of the people live in cold climate. By considering their health, they are likely to be affected by flu and cold. They are likely to be affected by flu and cold. While most of the people live in area of hot climate in terms of temperature, they are likely to be affected by malaria, diarrhea, cholera, as well as skin cancer diseases. So you may find right here, how do climate affect the health condition or the body condition of people lives in a particular area. Then from there, I can explain different things. They said most of the people lives in cold climate, they are powerful, see, more energetic. While most of the people live in hot climate, they are less energetic. Why? Because you find their bodies are not active. Why? Because remember, they do not need anything to generate heat. While most of the people live in a cold climate, they need something to generate heat. So you may find the body itself, it needs, for instance, food to act active so that it can generate heat. So in that particular concept, we may say most of the people live in a cold climate, they are not less energetic. While most of people who live in hot climate, they are less energetic. Okay, another factor is, because right now we are looking on how climate influences the human nature or human life. So the next point is human activity. You see? So most of the people who live in area of high rainfall like to be farmers, fishermen, and hunters. While most of the people live in area of little or no rainfall, especially in desert area, most of them, they are traders or businessmen. So you may see how climate influences the human life. So it may influence you to do either this or that activity, depending on different nature of particular area, or climate of a particular area. So apart from that, we have the transport system. So you may find most of the area which are characterized by high rainfall, they use water as a means or system of transport. You see, because they're using marine vehicles, because there are different water bodies caused by the presence of high rainfall areas. While most of the areas with no rainfall or with little rainfall, they use land or air as a system of transport. So you may find that why do they use either land or air as a system of transport? It is because of what? Of the climate of that area. The climate has influenced them to use either water bodies as a system of their transport, or land and air is a system of what? Of transport. Then from there, we have house construction. See? This is another point. Though it's a minor point, but this is a point. It's another point that house construction, you may find most of the people, they may construct their house with either gentle or steep roofs. Listen to me very careful. There are houses, it is a houses with gentle roof. This one, gentle roof. It is a house with gentle roof. And there are houses with steep roof. See? With a steep roof. See? A house with a steep roof. So they said the climate of a particular area may influence them either to construct a house with steep or gentle roof. Area with little or no rainfall at all, they normally construct a house of steep roofs, or sometimes the flat roofs. You see, for instance, area of Dodoma there, you see, Shinyanga, Singida, you may find most of the houses, they have either gentle or flat roofs. While most of the areas with high rainfall, they tend to construct their house with a steep roof for no easy destruction from what? From the rainfall. Then from there, I can say these are some of the factors where on how climate influences the lifestyle of the people in a particular area.
You are watching Darasa Online.
We have the question right here. Rainfall is dynamic and related to temperature of an area. The climatologist explains the influence of temperature and rainfall on human nature. See, the last question we did it to explain climate of an area. It influences the lifestyle of different people in a particular area. So right here, rainfall is dynamic and it is related to temperature of an area. As the climatologist explains the influence of temperature and rainfall on human nature. So it is the same question. See, right now it needs us to explain the influence of the temperature and rainfall on human nature. We have seen there that either temperature or rainfall has influenced the lifestyle of different people. How? We have seen on feeding side, dressing style, on human activities. We have seen on how or why do people construct houses with steep or gentle roofs. It's because of the climate of an area, of a particular area. Or sometimes how do body or health condition of a given people or person may be affected by the climate or nature of a particular climate. So this question, it is the same as the last one we did earlier. Then let's go to another question right here. The aeroplane was flying from one area to another between different altitude. The pilot observed the variation of temperature readings while flying. You see, by using the above explanation, explains the four types and 5 causes of such variation. See, so it needs right now to explain the causes and the type of this variation, because as the aeroplane flying from one area to another area, it means between different altitude, the pilot observes the variation of temperature readings. All together, it observes the variation of temperature readings between different altitude. So it means right now, the higher the aeroplane go, it means the pilot observe different temperature variation. The lower it goes, the plane is the temperature. The pilot observe different variation in temperature. It means what happened right now, they need us to explain the causes and the type of such variation. It means right now we have 2 types of variation. We have what we call the lapse rate. Why? Because the higher you go through the altitude, it means the temperature falls. The pilot observes the fall in temperature. And sometimes the higher you go between different altitude, it means the pilot observes the increase in temperature. So we know the higher you go, temperature increase. When temperature increase, the higher you go, or when the higher you go, there will be the increase in temperature. We call it the temperature inversion. And the higher you go, when we indicate or we consider or we notice the fall in temperature, we call it the lapse rate. Lapse rate refers to the higher you go, there will be the decrease in temperature. Temperature inversion will refer the higher you go, there will be the increase in the temperature. So the question right now, it needs us to explain the causes and the type of temperature inversion, and the causes and the type of temperature lapse rate or lapse rate. So welcome to the question. We have the question right there. The aeroplane was flying from one area to another area between different altitude. The pilot observes the variation of temperature readings. By using the above explanation, explains the causes and type of such variation. So they need us to explain the causes and type of such variation. So remember, the question said the aeroplane was flying from one area to another area between different altitude. From one area to another area between different altitude, whereby the pilot observes the temperature readings between different altitude. It means the pilot observed that sometimes the higher the aeroplane goes, there will be either the fall in temperature or the increase in temperature. It means there are 2 variations, as the question asked me. The higher you go, temperature fall, that is one variation. The higher you go, temperature it tends to increase. It means that is the second variation. It means right now the question needs us to explain the cause and the type of such variation. It means in other way the question needs us to explain the causes of temperature inversion and the type of temperature inversion, as well as the causes and the type of what we call the lapse rate. Okay, so let's go back because I know that you have a few concepts, you have some concept about this terminology, the two terminologies, the lapse rate and the temperature inversion. Let's go to lapse rate. Okay, what is lapse rate? What is lapse rate? Because the question needs us to explain the two variation. It means we have lapse rate as well as the temperature inversion. Temperature inversion. You see, so lapse rate is lapse rate. Lapse rate will refer to the decrease in temperature. Decrease in temperature the higher you go. It means the higher you go, if this is a land, it means right now the higher you go, instead of temperature to increase, the temperature tends to decrease. So the rate at which there is decrease in temperature, the higher you go, we call it lapse rate. See? So lapse rate, it is a decrease in temperature as altitude increase. That is lapse rate. We have two types of lapse rate. See? Type of lapse rate. We have the environmental lapse rate. Environmental lapse rate. Environmental lapse rate will refer to the normal decrease in temperature as altitude increase. It is caused by the saturation of the temperature at the atmosphere. It means when the atmosphere it is saturated at a certain point, we found that there is decrease in temperature the higher you go, and we call it the environmental lapse rate. And we know environmental lapse rate, we also call it the normal lapse rate, whereby the temperature it tends to decrease at every 100. Temperature tends to decrease at 0 degree, at 0.6 degree centigrade. I said this, environmental lapse rate will refer to the normal lapse rate where there is decrease in temperature, the higher you go. Let's go to this point. It means at every 100 meters, the higher you go, every 100 meter, it means there will be falling of temperature of this rate, 0.6 degrees centigrade, and we call it the environmental lapse rate. While we have another type of lapse rate, we call the adiabatic lapse rate. Adiabatic lapse rate. See? Adiabatic lapse rate will refer to the rate of decrease in temperature without addition or subtraction of heat energy. It means right now there is a decrease in temperature without addition or subtraction of heat energy, and we call it the adiabatic lapse rate. Remember, let's say this area is cold. Then we found there is decrease in temperature without addition of heat energy. See, maybe it's a hot energy, and we call it what? The adiabatic lapse rate. Or let's say this area is hot. Then if there will be the decrease in temperature, automatically the area of that area will be cold because it is hot right now. If there will be the decrease in temperature or the remove of the cold, it means the area will change into heat energy. Therefore, we say adiabatic lapse rate, it is the automatic, it's like the automatically change in temperature where the temperature tends to decrease without addition or subtraction of heat energy. Let me explain more on this concept so that someone may understood or may understanding what I mean. Adiabatic lapse rate. See, the word adiabatic means without addition or subtraction of heat energy. Listen to me very carefully. It means right now we are talking about the lapse rate. See, the environmental lapse rate refer to the type of lapse rate where there is the decrease in temperature in a normal way, where at every 100 meter, the higher you go, temperature tends to decrease at this rate. And we call it the environmental lapse rate. But at this point right here, at adiabatic lapse rate, it means refer to the change in temperature, you see, of a particular area without addition or subtraction of heat energy. It means sometimes you find a particular area is hot, for instance, without addition of heat energy. See, we didn't add the hot energy there, but the area changed it to hot or warm. And sometimes you may find the area is cool without the decrease in what? In a particular temperature of that area. We need this area. Look here, this area is hot. So we didn't subtract hot area in order to be cool, then the area to change it to cool. That is adiabatic, without subtraction of heat energy. Because if this area is hot, then we expect that, because this area is hot, in order for this area to be cool, then we need to subtract, to remove the hot area. You see? So we didn't remove the hot area, then the area or the temperature of an area changed to cold. You see? Or sometimes this area is cold. If we want this area to be warm, then we have to add hot heat energy right here. But right now we find that this area is hot without addition of hot heat energy. That's why we say adiabatic lapse rate refer to the change of heat energy of a particular area without addition or subtraction of heat energy. You didn't subtract heat energy of a particular area, then it changed either to cold. For instance, it is hot, it changed to cold. You didn't subtract or you didn't add any heat energy. Or the area right now is cold, is hot, then it changed to cold. You didn't add or subtract heat energy. That is what we call lapse rate. So let's go to the what we call the temperature inversion, because we have the lapse rate, as I've explained, that we have two types of lapse rate there. We have the environmental lapse rate and the adiabatic lapse rate. While the adiabatic lapse rate can be, as I said, it can be either wet adiabatic lapse rate, and the dry adiabatic lapse rate. Then from there, let's see what is temperature inversion.
You are watching Darasa Online.
We have seen what is lapse rate and its type. Right now, let's go to another variation, which is temperature inversion. So what is temperature inversion? Temperature inversion. Temperature inversion, we refer to the exceptional or abnormal change of temperature, where you find there will be or there is increase in temperature as altitude increases. It means right now, let's see here, it means you may find sometimes the higher you go, there will be the increase in temperature. See, we have seen in lapse rate or in lapse rate there is decrease in temperature. It means the higher you go, there is decrease in temperature, and we call it the lapse rate. But in temperature inversion right now, it means the higher you go, there is increase in temperature. That's why we say it is the abnormal or the exceptional lapse rate. You see, because it is the opposite of the lapse rate. The higher you go, temperature instead of decreasing, the temperature tend to increase. And we know lapse rate, temperature inversion, it occurs at the stratosphere and the thermosphere. Remember, at the stratosphere right here, temperature tends to increase from negative 50 degrees centigrade to 0 degrees centigrade. While at the thermosphere, temperature tends to increase up to 1,500 degrees centigrade. The higher you go, due to atomic energy and the ionization. So from there, let's go back. I want to explain something right here. Temperature inversion is referred to the increase in temperature as the altitude increase. Altitude increases. We have the causes of temperature inversion. The first, advection. We have the frontal. We have the radiation. We have what we call the air subsidence. The air subsidence. And the last one is presence of water vapor. Okay, so we have advection, frontal radiation, air subsidence, as well as the presence of water vapor is the causes of what? Of temperature inversion. So let's see what is advection. advection refers to the passage of two air masses with different temperature characteristics, where the one warm is cold, the other warm is warm. So when two air masses of different characteristics pass, it means warm air and the cold air mass. It means when the two air masses passes, so let's assume the warm air is much, is huge compared to the cold air. Automatically this warm air will cause the upraising of this cold air, see? So the higher it goes, because this one is more compared to this one in terms of volume, then you may find that the passage of these two air masses, the higher you go, you will meet the cold air, while the higher you go, you are going to meet the what? The warm air masses. So you say, because of the passage of two air masses, where at the first you will meet the cold air masses, you will feel cold, or the decrease in temperature, but the higher you go, you may find what we call the warm air masses, so you'll find the increase in temperature. And the passage of two air masses, we call it the advection. Then we go to the frontal. The frontal, it means frontal refers to the meeting of two air masses. Right here, they pass the passage. It means frontal refers to the meeting of two air masses, the warm air masses and the cold air masses, the warm and the cold air masses. So the meeting of the two air masses, sometimes they may form the molecule of either cold air molecule if cold air masses is much large or in volume compared to the warm, or it may form the molecule of warm air masses in case warm air is large or much compared to what? To the cold air masses. So at this point, we are assuming that the warm air masses are much. You see, they are more compared to what? To the cold air masses. So they will change the cold air into the warm. So the higher you go, instead of finding the cold, you find the warm condition at the what? At the atmosphere. That is another point. Then we go to the radiation. Radiation refers to the outgoing of radiant heat energy from the lower level of the ground to the, from the ground to the lower level of the atmosphere. So we find after the installation, this is the land. You see, this is the land. So right now, here, the sun is emit 100% of total solar energy which travels to reach the what? To reach the land. So after the installation, there will be what we call the outgoing of radiant heat energy from the ground to the lower level of the what? Of the atmosphere. You see, so the higher you go from right here, you'll find it coldly, but right here there will be warm. So the higher you go, you move from the cold area towards the warm air. So the higher you go, there will be the temperature inversion or the increase in temperature caused by the what? By the radiant heat energy. The process, we call it what? The radiation. So they said when there is falling of air molecule from the higher level of the atmosphere, it always causes the collision between the air molecule and the surrounding molecule of the atmosphere. So what happens at the upper level of the atmosphere, it will cause what we call the friction. You know, heat, it is a result of the friction. So due to the falling of those air molecules, that will undergo the friction between each air molecule at the atmosphere, automatically will cause what we call the production of heat energy at the atmosphere. Where later you'll find during air subsidence, it means the higher you go, there will be what? There will be the increase in temperature instead of the decrease in temperature. The other one is the presence of water vapor, where we know that at this point, it means this is the land at the either point of the atmosphere. Right now, the presence of different particulate or material at the atmosphere, they may either absorb. So some of the material that will absorb heat energy from the atmosphere, at the atmosphere, will cause the increase in what? In heat energy. So the higher you go, instead of temperature to decrease, temperature will do what? Will increase and cause what we call the temperature what? Temperature inversion. You can take this as a quiz. Describe the types of temperature inversion. Thank you, student, for being with me from the start to the end of the periods. I know you have learned a lot about climatology. We've seen some of the concept, temperature, insolation, the insolation rate. We have seen factor, how do climate related to temperature and rainfall affect human nature. We have seen temperature inversion as part of the temperature as well as the lapse rate. So because I've explained as a summary, I know from now on you can be able to learn more on climatology, because we have passed different difficult questions. Then until the next time, you are welcome on Darasa Online. Thank you very much for being there. Have a nice day.